systems of equations. So a system of equations just means I have more than one equation to figure out more than one variable. So we're going to start with two variables, and that means we're going to have two equations. So the first thing that you'll be asked to do is, let's say I have this system. So I have a system, that means it's more than one equation, and since it's two variables, I have two equations. Are the following solutions? So what does it mean to be a solution to a system of equations? Well, what that means is, let's take the first one. So this is my first example, part A. Let's take the point 4, -1. If this is actually a solution, that means it works in both equations. So I'm going to first test it in the first equation. So this is x and y, so they're going to replace x and y. So in the first equation, I get 4 plus 2 times -1 equals 2. That's 4 plus a -2 equals 2, and it works in that first equation. But just because it works in the first equation doesn't necessarily mean it's going to work in the other one, so I need to check that one as well. So that would be 4 minus 2 times -1, that becomes a plus 2 equals 6. So it works. This means this is a solution. Well, what about this one? And you may be asking yourself, well, why am I checking since the other one already worked? There are times where you can have more than one solution, and we'll see that happen. So if I replace the x and the y, I get -4 plus 6 equals 2. It works in that equation. On the other one, x minus 2 times y and it doesn't work in the second one. So this is not a solution to the system. Now we're going to review next how to find the solution. So the first method we are going to use is called substitution. Now, every method I show you will work on any problem, but sometimes one method is faster than the others. Okay, so the first step in the substitution method is to solve one of the equations for one variable. So I need to look back and see which equation is going to be the easiest to rearrange so that I have y equals blah, 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 or x equals blah, blah, blah. And to help us out, I'm going to number my equations. This is equation 1, this is equation 2. Which equation is going to be the easier one to work with? Well, equation 2 is going to be a lot easier to solve. I can take x minus 2y equals negative 3 and rewrite that as x equals 2y minus 3. Now this is what x equals. So let's think about that. If I knew x equaled negative 4, I can replace all the x's with negative 4. So what I'm going to do is I'm going to take that, substitute into the other equation. I'm not going to substitute it back into itself because everything's going to disappear. I'm going to take what I've rearranged equation 2 and use that in equation 1, meaning that in the equation 5x minus 4y equals 9, this expression is going to replace x because it's what x equals. So instead of writing x, I'm going to write 2y minus 3. Everything else from equation 1 is staying the same. I'm just substituting 2y minus 3 for x. So 2y minus 3 is going in for x. Now I have one equation with one variable. All I have to do is solve. So that'd be 10y minus 15 because I had to distribute. Combine like terms, 10y minus 4y, that's going to give me a 6y. I'm also going to add the 15 to the other side and get a 24. So y is 4. But in this solution, we have two equations with two variables, so I need to find both variables. So step 3, and I probably shouldn't have done these with circles since I labeled these with circles, but that's okay. We're going to back substitute to find the other variable. So I'm going to take that answer and plug it back in basically to either equation, but I'll give you a hint, in substitution this equation is always easier. I can take x equals 2y minus 3, and now that I know what y is, I can plug 4 in for y. So my solution is the coordinate point 5, 4. X, y. Now the next method we're going to review is sometimes called addition method. I like to call it the elimination method, so that's what I'm going to go with, elimination method. This is example 3. So let's consider, sure I'm not doing the exact one that's on the homework. I have a bad habit of that. Usually we'll use this method when it's not so obvious that I could use substitution. Like, here's my system. I got my two equations that are working together to help me find the two variables. And it's not so easy to solve for x or y. I mean, I can in either equation, but the problem's going to come into that I'm going to have fractions somewhere. So this is equation 1 and equation 2. Step 1, this is how I should have been doing them. Step 1 is to rewrite by multiplying one or both equations to make a coefficient be opposites. To make a coefficient be, that doesn't sound right. But what I want to do is I want to eliminate a variable. I want to be able to add these two equations together and something disappears. So notice in this, these have the same sign. These are both positive. This one's positive and this one's negative. I know if I have like a 4 and a negative 4 and I add them together, I'll get 0, which would eliminate something. Well, I kind of want that to happen. So I like that this is positive and this is negative. But I want them to match, just be opposite signs. So this is a 2 and this is a negative 8. If I had them both be 8s, like a positive 8 and a negative 8, then that would work. So what I'm going to do is I'm going to take equation 1 and multiply by 4. And when I say multiply the equation, I mean I'm going to multiply the whole equation by something. So I'm going to take equation 1 and multiply by 4. So 4 times equation 1. And I'm going to keep equation 2 just like it was. I'm not going to do anything to it. Now when I multiply that equation, I need to multiply the whole darn thing. So that's going to be 4 times 3, then 4 times 2y, that gives me an 8y, and then I have no idea what 4 times 48 is. I'm going to come off to the side. 48 times 4, I do not have a calculator handy, 32, 192. And what I'm going to do next is add the two equations together. So 12x plus 9x is going to give me 21x. 8y minus 8y, they're going to disappear. And then I've got 192 and a negative 24, so that's going to be an 8. 168. Now I'm going to have to divide. Whew, I am wishing I had not done that. But this is kind of easy. That turns out to be an 8. 8 times 2, 8 times 1. Yep. Now I need to find the other variable. So step 2 is to back substitute. So I need to take that 8 and plug it into either equation to find y. I'm going to pick the first one just because I think it'll be easier. So I'm going to plug in 8 for x. So I have 3 times 8 plus 2y equals 48. So that's 24 plus 2 times y. 2y equals 24. So y is 12. So my solution is the point 8, 12. I think it'd be helpful to do another one of these. So I'm going to squeeze that in down here. So let's do another one. Now, I want you to notice something on this example, and that is that they're not lining up right. Like up here, the x's were in a line, the y's were in a line, and the constants were on the other side. It is much more helpful to have it lined up where you have x plus y equals constant. So I'm going to rearrange both of them just to get them in order. So the first one would be 2x minus 7y equals negative 17. And then this would be a positive 3x plus 5y equals 17. All right, I think on this one I'm going to get a little crazy. Okay, so this is equation 1 and equation 2. What if I multiplied the first one by 3 and the other one by -2? That would give me a 6 and a -6. I'm going to try it. So I'm going to multiply 3 times the first equation and -2 times the second equation. So 3 distributed would give me 6x minus 21y equals -51. -6x minus 10y equals, what's that, -34. That gives me a -31y equals -85. Negative divided by negative is going to be positive 85 over 31. Now, don't freak out that you got a fraction. A fraction is a perfectly good answer. People freak out for no reason. So, I'm going to plug that in, but I'm going to do something a little bit different, and I'm going to kind of rearrange one of those equations to make it a little bit easier. So I'm going to take this equation, equation 2, and rewrite that. Well, actually, I like this very, very first one up here. It already had x, kinda, equals y on the other side. And so I'm going to be taking 7 times y minus 17 divided by 2. I really don't want to do all of that by hand, so you can use your calculator. And I found my calculator. Yay! Now, if you have, and I believe you can still do this with Desmos, I'm going to be making a fraction, 7 times a fraction, and the fraction was 85 over 31, minus 17 divided by 2. Now, if you enter it in as a fraction, it'll give you your answer as a fraction, so that's helpful. You could have also wrote the decimal. That would be fine, but it's not exact. And there's our solution. We're going to do a couple of more examples just because some weird stuff can happen. And I want you to see what happens, what can happen. So we'll do a couple more of examples of these. All right, so which one do we want to vote off the island? Who are we going to try to eliminate, X or Y? I'm going to go with the X's because 4 and 6 both can become 12s. So what I'm going to do is I'm going to take the first equation and I'm going to multiply that one by 3 times by 3. And I'm going to take the second equation and multiply by a -2. And let's see what we get. So 3 times 4x is going to be 12x. 3 times 6y is going to be 18y equals 36. Multiply 3 by -2. And I already see something weird. When I add these two equations together, both the x's and the y's cancel out. Remember, that means I have a special situation. My two options are that there is no solution or infinite solutions. Well, the question you need to ask yourself is, do we have a true or a false statement? Does 0 equal 12? No. That's a false statement. So that means we have no solution. You could use the empty set, which means there's no solution at all, or you can write the words no solution. Okay, in this system, I have one of the equations already solved for y. So this is a perfect example that I would use substitution for. Because y equals this, that means I can replace y with that whole thing. So I would have 15x minus 5 times 3x minus 2 equals 10. 15x distribute. 15x minus 15x. The variables disappear. And I'm left with a true statement. That means there are infinitely many solutions. Now, graphically, what this means, let's think about graphs. When we end up with one point, that means I have two lines that are crossing at one single point. No solution would mean that they are not crossing ever. That would mean that they're parallel. What would infinitely many solutions mean? Well, that would mean I have a line and I have a line right on top of it. It means we actually have the same line.